Hello students, this is a video on the QA topic tests that are available on the Bodhee Prep app. The idea of these tests is once you cover the basic concepts of a topic, you want to know whether you'll be able to use those concepts in an exam or not. So after every topic, you take these tests. With every test, there is a video which gives you the overall analysis of the test and the solutions to all the questions. And there are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below, so make sure you download the app and make the most of these tests. This specific video is the fourth test on polygons. Overall, in terms of analysis, it was a moderate level of difficulty test. 5 out of 8 questions being done in about 17 minutes would be considered a 95 plus percentile attempt. 5 questions net correct. If we look at the questions, says consider the 12-sided polygon A, B, C, D, E, F, G, H, I, J, K, L. A, B, C, D, E, F, G, H, I, J, K, L has each of its side is length 4 and also two consecutive sides form an angle of 90 degrees. So this is 90 degree, this is 90 degree and so on. AG and CH meet at M. What is the area of ABCM? ABCM, this part. Now we can say that area of ABCM will be nothing but area of, we join LI, we join CF. So area of rectangle ABGH, ABGH minus area of triangle AHG minus area of triangle CMG. So from this rectangle, if we remove this entire larger triangle and this smaller triangle, we will get our required area. Now ABGH is straightforward. AB is 4. BG will be 4 plus CF and D will be equal. So this will be 4, this will be 4. So 4 plus 4 plus 4, 12. Area of ABGH becomes 4 into 12. Area of AHG is also straightforward, half of AH, which will be 12 into HG, which is 4. And therefore CMG is left. Now, what do we do for CMG? We drop a perpendicular from here. Suppose this is MX and a perpendicular from here. Suppose it is MY. We can say that triangle MAH is similar to triangle MGC because these two are vertically opposite angles. These two angles will be equal since AH and BG will be parallel. In similar triangles, ratio of height is equal to ratio of sides. And therefore, we can say AH upon CG will be the ratio of side. This should be the ratio of height. Height for this triangle is MY. Height for this triangle is MX. AH would be 12. CG would be 8. MY and MX. So we can say MY is to MX has to be in the ratio divided by 4. 3 by 2. Also, YX will be equal to HG. Therefore, MX or MX and MY divide the length 4 in the ratio 3:2. So MX will be 2 by 5 of XY, 2 by 5 times XY, which will be 2 by 5 times of HG or 4. So this becomes 8 by 5. And therefore, for triangle CMG, we can say area will be half MX, which is 8 by 5, into base, which is CG or 8. This value becomes 48 minus 24 minus 32 by 5, or 24 minus 32 by 5, or 120 minus 32 by 5, or 88 by 5. Option C becomes my answer. I would say this question would be a moderate to difficult level question because joining the lines LI and CF may not strike early. Without that, looking at the similar triangles is also difficult. Easily about 3 minutes to solve the question. Joy has 30 thin rods, one each of every integer length from 1 through 30 centimeters. Joy, she places the rods with lengths 3, 7, 15 on a table. Then wants to choose a fourth rod that she can put with these three to form a quadrilateral with positive area. How many rods can she choose? Suppose the fourth rod is of length n. We keep it as the base and we join the other three rods of length 3, 7 and 15 to form the quadrilateral. Now, what will always happen is n has to be less than 3 plus 7 plus 15. Because if n is equal to 3 plus 7 plus 15, then these rods can be kept straight on n without creating any area. So like triangle, sum of two sides is greater than the third side. In the quadrilateral, sum of three sides has to be greater than the fourth side. Similarly, if we keep 15 as the base, then 3, 7 and n have to have a length which is greater than 15. And therefore, from here we say n has to be less than 25. From here we can say 3 plus 7 plus n is greater than 15 or n is greater than 5. Therefore, the length of n should be between 5 and 15, 5 and 25. This gives us equal to sign is not there in 5 and 25. So, between 5 and 25, which will be 25 minus 5 minus 1. That is 19 numbers are possible. Out of these 19, 7 and 15 already have been used. Therefore, total possible values of n will be 19 minus 2, which is 17 because two of the values have been used. Answer becomes 17. In terms of concept, probably moderate, but it is very easy to make a mistake here while counting the solutions. Therefore, moderate to difficult. Solving time should be around 2 to 2.5 minutes. There are two concentric hexagons. One hexagon, the other hexagon. Something like this. Each side of both the hexagons is parallel. Each side of the internal hexagon is 8. And the distance between parallel lines is 2 root 3. Would find the area between both the hexagons in centimeters square. Okay. Now, if we look at the distance between the two parallel sides of the inner hexagon, this will be 8 root 3. Plus, here the distance is 2 root 3. Here the distance is 2 root 3. So we can say the distance between parallel sides of the larger hexagon will be 2 root 3 plus 8 root 3 plus 2 root 3, which will be 12 root 3. This means the side of the larger hexagon will be 12. Because the distance between parallel sides for hexagon with side A is root 3a. So since this side was 8, this becomes 8 root 3 plus 2 root 3 plus 2 root 3, 12 root 3. So this side has to be 12. Now the area between the hexagons will be simply the area of the larger hexagon minus area of the smaller hexagon. Area of the larger hexagon is 6 root 3 by 4 into 144, 12 square. Area of hexagon is equal to 6 equilateral triangles minus 6 root 3 by 4 into 8 square. So this becomes 6 into root 3 by 4 into, taking 6 root 3 by 4 common, 144 minus 64, which is 6 root 3 by 4 into 80. 4 20s are 18, therefore 120 root 3 centimeter square becomes the area between the two hexagons. I think the first part is something that requires some amount of application. After that, it is just putting the formula. So 2 minutes to solve, moderate level of difficulty. 3 hexagons of increasing size are shown below. Suppose a dot pattern continues so that each successive hexagon contains one more band of dots. How many dots are there in the next hexagon. So here there is one dot. Here we have 3, 2, 2, 3 and 2, 3 and 2. Central number goes from 1, 2, 3. Here the central number will be 1, 2, 3, 4, 5. On the left side where there will be two numbers, 4 and 3. On the right side there will be two numbers, 4 and 3. Therefore, for the next one, the central number will be 7. There will be 3 numbers on the left, 3 numbers on the right. Here there was 1 number on either side, 2 numbers on either side, so 3 numbers, and each number will reduce by 1. So 7, 6, 5, 4. 7, 6, 5, 4. The sum will be the number of dots in the next hexagon. This comes out to 6 plus 5, 11 plus 4, 15, 15, 15, 30 plus 7, 37. Or what we can look at, here the total number of dots is 1. Here it becomes 1, 2, 3, 4, 5, 6, 7. Basically 1 plus 6. Here it becomes 1, 2, 3, 4, 5, 6, 7. Or just look at the extra number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1 plus 6 plus 12. And therefore, basically, multiple of 60 is being added. So the next will be 1 plus 6 plus 12 plus 18, which is again 37. This way or that, both cases, I would say, because if you're doing it for the first time, therefore moderate level, but the solving time should not be very high. Each interior angle of a regular polygon is 140 number of sides. Interior angle plus exterior angle is equal to 180. If interior is 140, external angle will be equal to 180 minus 140, that is 40. And we know that external angle of any polygon is nothing but 360 upon n, where n is the number of sides, and therefore n becomes 360 by 40, which is 9. Option D becomes my answer. Easy question, less than a minute and a half to solve. Each angle of a regular hexagon, this is 120. This is a value that you would actually remember, but even if you don't, each angle is given by 180 minus 360 by n. N is the number of sides, so 180 minus 360 by 60 by 6, which is 180 minus 60, 120. Again, the easiest question that you can come across, less than a minute. If one of the interior angles of a regular polygon is equal to 5 by 6 times of one of the interior angles of a regular pentagon. So first let us look at interior angle of a pentagon. This will be 180 minus 360 by 5. Number of sides is 5 in a pentagon. So 180 minus 72, which is 108. Now the interior angle of the regular polygon is 5 by 6 times of this angle. So the required angle is 5 by 6 times the angle of a regular pentagon, which is 108. 6 18s are 108. So this becomes 90. Then the number of sides of the polygon is, with 90, the regular polygon is has 4 sides, a quadrilateral. So B becomes my answer. Even at this point 4 does not strike, we can put the value and get the answer as 90 is equal to 180 minus 360 by n, or 360 by n is equal to 180 minus 90, which will be 360 by n is equal to 90, or n is equal to 360 by 94. But I think at this 4 should be clear. Again, overall easy question, maybe a minute and a half to solve. Sum of interior angles of polygon is 1260 degree. The number of sides of the sum of interior angles of an n-sided polygon is simply n minus 2 into 180. For a triangle, it is 3 minus 2, 180. For a quadrilateral, it is 4 minus 2 into 180, and so on. Now, sum of interior angles is given as 1260. This will be n minus 2 into 180, and therefore n minus 2 is 1260 upon 180. This will come out to 7. 7, 8, 56, 5, 12. So n minus 2 is 7, or n is equal to 7 plus 2, which is 9. Option D becomes the answer. Again, easy question. A minute and a half. If you look at the overall test, therefore, we are looking at about 5 questions in 17 minutes. Which would be these 5 questions? For me, they would be 4, 5, 6, 7, and 8. Which are these? may not be able to do this every time in the exam. Construction is involved. Again, this was a straight, relatively easy property, but more. I've used this property more in triangles and therefore might not strike every time. Again, unless we're very comfortable with hexagons, this might not be the easiest of questions. From here, I'm counting questions because this is a pattern which I will eventually be able to draw if nothing else. This was again formula based. Actually, this was nothing based. This was formula based. This was formula based. The formula based questions are repeatable, and therefore, for me, 4, 5, 6, 7, 8 would be my sure shot 5 questions.